Okay, so far we have learned how to input the transfer function into the command window, right? And then we run a simple command, and then we can see the parameter of the systems, right? And then secondly, we also able to write the command, Matlab command, into the script M file, and then we can run the file so that we can see the output of the file. All right. Okay. The third one we're gonna see is we can also model in Simulink. So what we have to do is we go to new button here, then we click Simulink model here, right? Okay, Simulink model. In Simulink model, when you launch the Simulink model, then we can click on the blank model here, right? Blank model. Click that blank model. So there will be a Simulink windows open for you, right? So okay, now from this Simulink window, right? So we need to click on the library browser. You see that small colorful icon here, red and blue color icon. Click that, so it will come out the Simulink web browser. And then okay, and then okay, in Simulink library browsers, we have there are so many things inside here. So at this stage we focus on the how do we model the transfer functions. So we have to go to the continuous library, then look for transfer functions here. Okay, look for transfer function, and then click and drag into the page. All right, so now we have that transfer function. So if we want to change that transfer function, we just double click this. All right, double click that one. You see that numerator 1, so it is 1 here. Denominator coefficients, so it is 1 1 because the coefficient for s is 1, and then this one is 1, right? So if you were to change to s plus 2, the second one has to be 2, and then it become s plus 2. All right, so if we were to change to s squared, so we just add this, maybe s squared plus 3s, for example, plus 2. Just input 1 3 2 instead. Okay, then okay, we have to, okay, now we have this. So we just need to input the coefficients of the denominator, right? Okay, now we have this, and then what we have to do is we need to supply the inputs to the transfer function, right? Rs. So we need to look for the input in the source. Okay, source. So there are so many inputs here. Okay, look for step input. Okay, let's say step input. We just drag and drop here. All right, step input. Okay, so we can change the step values. Step time is 1 second, initial value 0, final value 1. We can change to 2, 3, 4, 5 according to the, if it is 1 over s, we just put final value 1. If it is 2 over s, that's 2 over 2 here, right? So in this case, we put, just remember, we put 1 here, okay? So the step input is 1. It's going to the transfer function, our transfer functions, and then we need to see the output. Okay, the outputs have to be under the sync here, sync. So there are so many, you can display, you can terminate, graph, whatever. So in this case, we want to see the response. You just click the scope and drag into our model. Okay. Okay, now we have already complete the control diagram, we have input, we have transfer function, we have scope here. All right, once we've done this, we click this run button here. All right, run button, just click here. Okay, so this is the simulation time. So we see we put it 10 seconds, and then we need to observe the output. So you need to click the scope here, and then you see there's a response, right? So you see that the steady state is 0.5 in this case, right? So it is if we can prove using the inverse Laplace through calculations as well. So this is our final state value, right? 0.5. Just close it. Okay, right now if I were to change this step input to 2, right? So 2 over S, I need to run again. Just double click here. So see the output is 1 now because I changed the step input, right? So the answer, the response, the output response should be similar to the Matlab response that we ran before, right? So you can verify with Matlab. Okay, now I just put it on side. This is our model. This is our library browser. I want to see in the Matlab, right? So you have to do the same as equal to TFS. Okay, that's that. Okay, then we have to input the same transfer functions like before, right? So let's say we consider that the system's equal to 1 over, right, s to the power of 2 plus 3 s plus 2. Okay, so that's a system similar to the Simulink model. So that's our system, right? So let's run a step command, right? Step system. Okay. All right. Let's see this. Okay, this, remember this one is we already we changed that to the input to 2 of S, so we change back to 1 of S, right? So we change back this to 1. Okay, and to run again. Okay, you see that they are very similar, right? 0.5, the response looks similar. Start from 1. So because we set the step input start from 1, right? So that's how you see it start from 1 here. So in fact, you can change this step times 1, initial value, final value. So step times 0. Okay, run again. So it start from 0. You see, it's the same, right? Exactly the same. So now if you were to change the input is to S, we just run the command step, and then you just multiply by 2. 2 multiplied by systems. All right, and then you see the output is increased to 1. All right, the final state here. So same things here. We just change this to 2. Okay, and then run again. Okay, there you go. We have the same response. So you can choose whether either you want to run in the command windows in the Matlabs or in the Simulink's block diagrams here. So right. Okay, hopefully this will help you to create a model in Simulink. So you'll save it, file, save as to SLX model, and then you can open it again, so you don't have to create a new one. All right, thank you very much.